Hello there, this is Peak Tech Channel. My name is Abaya Khatov, and here we discuss cryptocurrency market and everything related to cryptocurrency. Our today's topic is altcoins, and we've already started observing them in the first part. This is the second part, so check out the first part if you haven't seen it already. For now, we start the second part. And we're about to start with the smart contracts. You may have heard that cryptocurrencies are programmable money, but what does that mean and how is it achieved? Smart contracts are simply pieces of code that are executed by a blockchain network to perform some set of tasks as defined by the smart contract author. Once deployed, the code of a smart contract can never be altered, and it can be automatically executed or enforced without the need of a third party. Why do we need smart contracts? Well, cryptocurrencies are distributed ledgers are being kept in sync by the cooperation and agreement between multiple computers. At their core, cryptocurrencies allow you to transfer ownership of units of the currency from one person to another. And this transfer is registered in the ledger for perpetuity. But what if you want to do more than just transfer units of some currency? What if you want to transfer these units only after some specific amount of time has passed, or only if some event has occurred? Enter smart contracts. Smart contracts make use of the immutability property of blockchains, and they are not reversible. How are smart contracts created and where are they deployed? Well, smart contracts can be written in different programming languages, um, depending on the smart contract platform they are destined for. A plethora of smart contract platforms exist today, some of the most well known being Ethereum, Neo, EOS, Cardano, Stellar, VeChain, and well, the list is long. On Ethereum and many other platforms, smart contracts are written in a language called Solidity, which was designed specifically for smart contracts, whereas on other platforms such as Neo, you can write smart contracts in generic languages such as C Sharp, Java, and Python. What are the use cases of smart contracts? While the use cases for smart contracts are limited by little more than the creativity of the author, the most common use case for smart contracts is that of token creation. Most crypto tokens are nothing more than a smart contract running on a smart contract platform. In fact, this use case is so common that there are standards for how to create tokens, um, how to create tokens on most, if not all, smart contract platforms. On Ethereum, this standard is called ERC20, whereas no Neo, it's called NAP5. These standards define a minimum set of functions that a smart contract must have. The beauty of public smart contract platforms is that anyone can write and deploy a smart contract and have it executed on all the computers in the network. Since a smart contract uses resources on all the computers in the network to run, invoking a function of a smart contract is not always free. Most smart contract platforms measure the complexity of the invoked function to determine its cost. Once deployed, a smart contract cannot be changed. Smart contracts sometimes require input from the real world. Imagine a smart contract that allows people to enter wagers on the outcome of a football match. The smart contract is perfect for managing the funds and make sure that those who win get their winnings and those who lose get nothing. But what it can't possibly know is the outcome of the football match. For this purpose, one or more third parties are needed to feed the smart contract, with the result of the football match by invoking a function. Such a third party is called an oracle. An important property of a smart contract is that it verifiably does exactly what it says it does, nothing more and nothing less, and its code cannot be changed once it has been deployed. This eliminates the need for transacting parties to trust each other because they know what the smart contract does. This is very useful in a globalized world where those transacting might have never met and might be very far away from each other geographically. In the future, there's a good chance that smart contracts will facilitate most transactions that we humans make with each other. In everything from banking, insurances, digital identity management, supply chain, gaming, gambling, you name it, the use cases for tamper-free, verifiable, programmable interactions via smart contracts are vast, and we are just scratching the surface. ERC-20. ERC-20 might sound like a military code name or something, but in reality, it is much simpler than that. An ERC-20 token is simply a token built on the popular cryptocurrency platform Ethereum. ERC-20 stands for Ethereum Request for Comments. The 20 is simply the number that was attached to the original proposal. ERC-20 denotes the nine functions a cryptocurrency should abide to operate within the Ethereum network when creating a cryptocurrency. The primary currency on the Ethereum network is Ether. However, the Ethereum blockchain supports a multitude of cryptocurrencies that comply with ERC-20 standards. This allows individuals to create their own cryptocurrency without having to rebuild the entire wheel, so to speak. What are the functions of ERC-20 tokens? Well, ERC-20 tokens must have 9 built-in functions. 6 of them are mandatory, 3 of those are optional, in order to operate fluidly within the Ethereum network. These functions maintain the ability of ERC-20 tokens to communicate effectively with each other. The 3 optional functions are simple. When creating a token, you have the option to give your token a name, a ticker symbol, like MCO, CRO, ETH, or something, and adjust the divisibility of the token, how many decimal places your token will support. The rest 6 are more technical and we will skip them here. The birth of the ERC-20 standard allows all of the projects on the Ethereum network to interact with one another without the need to program those interactions on a one-to-one basis. It ensures complete flexibility and fluidity between all ERC-20 tokens. ERC-20 is not as complicated as it seems. It is merely a set of 9 functions that allow projects built on the Ethereum network to interact seamlessly with each other in a controlled and predictable way. The standard also acts as built-in security within the Ethereum network by ensuring certain constraints that mitigate illegitimate activity. The creation of the ERC-20 standard is directly responsible for the massive amount of projects built on the Ethereum network, as well as the 2017 ICO boom. It allowed the average user to design and implement their own cryptocurrency projects with ease. This is the reason it remains the most popular token format for today. Stable coins. These stable coins is a type of cryptocurrency having its price pegged to a specific asset, which is most often, but not always, the United States dollar. The near perfect one-to-one peg is achieved through various methods. There are 4 major ways to maintain the pegging Those are reserve of pegged asset, dual coin, algorithmic, and leveraged loans. Reserve of pegged asset. It refers to a fully collateralized system backed by the pegged asset, where arbitrators are incentivized by helping to stabilize the price. When the price of the stable coin is lower than the pegged asset, the arbitrators can buy cheaper stablecoin, which can then be redeemed for $1 each. Similarly, when the price is higher than the pegged asset, they can sell the coins to gain profits. When a user wants to exchange their stablecoin for real US dollar, the stablecoin is burnt and the user is wired the equal amount of dollar to their account. This system works only when the company, government, or private party, also known as custodian, issuing the stablecoin establish trust with the user. The issuer of these stablecoins should be regulated and audited regularly to provide transparency to its users, establishing and deepening the trust between issuer and user. Dual coin. Two coins exist in these kinds of systems where one is the pegged coin, while a secondary coin is used to absorb the volatility of the pegged coin. This is not a common way to issue stablecoins due to regulatory reasons. Algorithmic. These kinds of stablecoins use a fully algorithmic approach to adjust the supply of the stablecoin in response to price fluctuations. A stable algorithmic coin only exists in theory, and not even one is out there in the market now. For instance, a recent algorithmic coin project called Basis has completed its ICO but failed to deliver its promise due to regulatory concerns. Leveraged loans. This kind of stablecoins is backed by an over collateralized system. The most successful examples is DAI, in which the stablecoin is backed by PETH or PETH, and its value is correlated to Ethereum. Since the collaterals are more volatile in terms of price, users need to have more than $1.5 worth of PETH to borrow $1 of DAI. If the price of the collateral falls sharply, the debt position will be liquidated and the remaining amount of collateral will be returned to the user. In the DAI system, users are incentivized to help in stabilizing the price and liquidation of the collateralized debt positions. All operations in the DAI system are executed by smart contracts, so it is reliable and decentralized. Common examples of stable coins. Some examples of stable coins include Tether, True USD, Paxos, Gemini Dollar, USD Coin, and DAI. Among them, only DAI belongs to leveraged loans, while others use reserve of pegged asset to stabilize their values. Simple classification of cryptocurrencies. Considering these, there are over 2,000 cryptocurrencies on today's market, investors face a veritably overwhelmed choice for these cryptocurrencies. There are quite a lot of tokens, but they can be classified by groups. Different kinds of token classifications exist when considering different dimensions. A common and simple classification is introduced for you there on your screens. Utility tokens. Utility token is a digital asset that is used to finance the network by providing its buyers with a guarantee of being able to consume some of the network's products. Security token is a digital token that represents the value of an underlying asset like traditional private security. It can represent shares in a company, interest in a fund or trust, a home, an art collection, a farm, or essentially any asset that a person can own. um, Cryptocurrencies, tokens can be classified as currencies if they were created as the target of payment for goods or services external to the platform running the token. For example, Bitcoin is treated as a currency as it was created with the intention of replacing fiat money. As such, Bitcoin holders are able to use their Bitcoin to purchase goods and services from shops, online retailers, and other merchants. And here we come to consensus algorithms. In the previous, so, um, well, I hope that you already know that consensus, what consensus is and why a cryptocurrency requires consensus between nodes in order to validate transactions. However, not all cryptocurrencies reach consensus in the same way. These different methods are called consensus algorithms. The consensus algorithm is a cryptocurrency uses is a uh, th- uh, the consensus algorithm that cryptocurrency uses is a fundamental part of its design. Actually, it determines how many nodes the network will support, how easy the network is to attack, and how fast the network can confirm transactions. For those reasons, it is important to choose a consensus algorithm that can achieve the right amount of decentralization, speed, and security for each use case. There are many algorithms and more are being developed every day, but here are the most popular. Proof of work. The oldest and most popular cryptocurrency, Bitcoin, uses the proof of work or POW consensus algorithm, a concept presented originally in 1993. In proof of work, miners compete using computers of higher speeds in order to solve a mathematical problem. The first miners that solves the mathematical problem then confirms the transactions in that block and receives the block reward and transaction fees. As the total processing power of the network increases, the math problems become more complex so that they are not solved faster. In this consensus algorithm, a 51% attack can only be done by having 51% of the total computing power of the network, which is why Bitcoin is so difficult to attack today. Proof of stake, or POS, was a consensus algorithm first implemented by Peercoin in 2012. It is seen as one possible solution to the large amount of electricity used by proof of work, because like the other systems that follow, it does not require computers to compete in order to confirm transactions. Instead, proof of stake uses random selection weighted based on a node's coin base in order to select which node will confirm the next block and receive the corresponding block reward. Delegated proof of stake, or DPoS. This is a type of proof of stake that reduces the number of nodes that participate in the validation of blocks. It does this by requiring users to vote for representatives who will validate blocks on their behalf. Block rewards are then passed down to the voters of the nodes in a similar way to a mining pool. By having only a handful of validating nodes, the transaction speeds are much higher. However, some question the level of decentralization these platforms can achieve. EOS is most famous for using this algorithm. However, it has quickly become one of the most popular other than proof of work due to its faster transaction speeds. Unfortunately, having a low number of nodes increases the chances of collusion. And as demonstrated by the public Lisk cartel that formed, this can be a very real threat. Byzantine fault tolerance. Practical Byzantine fault tolerance is a method of reaching consensus as long as at least 2 out of 3 of the network is trustworthy. The nodes in these cryptocurrencies are pre-selected and vote in BFT rounds in order to validate blocks. This method of consensus is normally more scalable with high throughput and fast finality. Unfortunately, they are more centralized since they cannot support a large number of nodes. BFT consensus is deterministic in nature and has a fixed amount of participants in every round of voting. So that was pretty much it. I hope the video and the information was useful for you. I'll see you next time.